Okay, let me quick talk about the factoring. We talked about this one where it's a trinomial. So if it's a trinomial, just draw it, and the leading coefficient is 1. Just draw your parentheses. Ask yourself, how do you get r to the 4th? R times r times r times r. Well, you're going to take r squared and r squared. Think of things that multiply to give you negative 18. You want the pair that adds up to positive 3. And so I start to list them. I see that if I take a negative 3 and a positive 6, so there's my factors. Again, you can double check it. R to the 4th, 6r squared and negative 3r squared for your outer and inner product. 6r squareds minus 3r squareds, yep. And negative 3 times 6 is negative 18. All right, if they give you grouping, or if they give you 4 terms, you're going to factor by grouping. So what you're going to do, it's similar to what we did for number 9, group these two together. What can you take out? Well, they both have n's. In fact, they have n squared in common. So if I take 2 of those n's out, I'm left with an n. Here, if I take those n squareds out, I'm left with a minus 7. Do the same thing here. I can take out a negative 4. Draw my parentheses. If I take the negative 4 away, I'm left with an n. If I divide that by negative 4, I'm left with a minus 7. So you're dividing that by negative 4. Double check, you still get what you started with, negative 4n plus 28. So if this works, those two have to be the same, n minus 7. That's one term. What's left out here is your other factor, n squared minus 4. Now you should check, can this be factored? And if you look at that, I can ask myself what multiplies to give me n squared, n times n. I have a minus 4. If I put a minus 2 and a plus 2, they will add up to 0 n's, which is what I want, but then negative 2 times 2 is my negative 4. So there's my factors of that. So you factor by grouping. Okay, then on the back, just real quick, make sure you know the rational root theorem. There's one question like this. Remember, this is P and this is Q. So think of the things that multiply to give you P. Negative 12, or 12. We'll just look at 12. 1 and 12, 2 and 6, 3 and 4. So P can be any of those combinations. Q is this number. So the only way to get 5 is to take 1 times 5. So you have to do all the combinations, positive and negative, of P over Q. So don't forget, it's this factor over here, the factors of P over Q. So let's just start doing that. I'm going to start with 1. 1 over 1 and 1 over 5. And this is all plus or minus, so I'm going to just put that in parentheses. I'm going to do 2 over 1 and 2 over 5. Oops, I'm going to keep my parentheses, I guess. Then I'm going to do 3 over 1 and 3 over 5. And then 4 over 1 and 4 over 5. 6 over 1 and 6 over 5. And 12 over 1 and 12 over 5. So just do all of those combinations. 1 over each of those, 2 over each of those Q's, this P over those two, and just do all of those combinations, write it down. Plus and minus those. Make sure you show that plus or minus. Okay, and then the last ones, you're going to use that to figure out what to multiply by, so you can't factor these, so you're going to have to use synthetic division. So you need to think of the things, P over Q, so you're thinking of all the factors of 20. 1 and 20, 2 and 10, 4 and 5. Plus and minus all of those numbers. This is just a 1, so I don't have to worry about putting it over anything. So I started trying 1, negative 1. When I got to negative 1, synthetic division, I put my coefficients, bring down the 1, multiply and add, multiply, add, multiply and add. I find out that the remainder is 0. That's good. That means that's one of my roots. So what's left is x squared plus 9x plus 20. So now I see that I can factor that quadratic into x plus 4 and x plus 5. So now when I set those roots equal to 0, I get negative 4 and negative 5. So I've got my one root from here, from the division, because I got a remainder of 0. What's left in the answer row, I could factor it, but then I set each of those factors equal to 0, and then I solve those equations. So I'll jump to 15. 15, same kind of thing. Again, it had to be pairs of factors of 16, so I was thinking 1 and 16, 2 and 8, or 4, and it's still over 1, so I just have to do the plus or minus of all of those numbers. I tried negative 1, and it came out to 0. So now I was left with this, but this is x to the third minus 12x plus 16. I still can't factor that, because remember, these are the coefficients. So that would be 1x to the third, no x squareds, negative 12x plus 16. So I can't factor that, so I kept going. I should try negative 1 again, and I did, and it didn't work. So then I tried 2, and I did the synthetic division. I got a 0 again. Once you get it down to a quadratic, which means you have to have 3 terms here, 1x squared plus 2x minus 8, now you can say, okay, I've got those 2 roots, I have to come up with my other 2. So now I can factor those. That factored into x plus 4 and x minus 2. Because I needed the pair of factors that multiply to give me negative 8, but they're going to add up to 2. And so now I set that equal to 0, I get negative 4, set that one equal to 0, and I get 2. So with this one, it kind of puts everything together. Do you know the rational root theorem, so you know which things to try? Can you do synthetic division? And then once you get it down to a quadratic, can you factor it? So all of the things that you're talking about all come into play into that one problem. So there are 2 of these kinds of problems that you have to do. Okay, so on the test there are 2 that you have to do the leading coefficient, degree, and end behavior. 1 where you have to synthetically divide, just checking to make sure you can do it. Remember, this is the root, so you're dividing by that number. That's not the factor. The factor is x plus 6. The root is negative 6. You have to be able to factor. There are 3 of those. Look for the common factor. If there are 4 terms, factor by grouping. If there are 3 terms, you're going to have to factor. If it's just a 1 as a coefficient, it's a little bit easier. If it has a number, a 5, like this one, 5, it's a little bit harder, but you definitely can factor it. If there are 3 terms, same thing. We factored it, even though this was an x to the r to the 4th and an r squared, we still can factor it in that same method of seeing what times itself gives me r to the 4th, looking at pairs of factors of negative 18. You wanted the pair that added up to 3. Okay? And then on the back, just making sure that you know the rational root theorem. So this one will be a little bit uglier than what the actual problems you have to do. All you're doing is listing them. So this one's P, write down all the factors of P, all the factors of Q, and every combination, P over Q, P over that Q. This P over Q, P over Q. And then the last one that puts it all together, think of the things you're going to try to divide by. You're going to keep dividing until you get 3 terms right here, after you have a 0. Once you have 3, now you know you've got a quadratic. This many x squareds, this is x, and that's your number. Factor that and set each of those factors equal to 0. Okay? There are 2 of those kinds of questions on the test. And remember, this is only the non-calculator part. I can do another video on the calculator part on Monday.